SC4K. So as we started the Innovation Hub and we are starting this Mechatronics classes, so we want to make sure you all are having some basic knowledge to do those things. Like example, you should have a good knowledge about circuits and how the current flow happened, those kind of very basic thing. So this is for the beginners from the very basics of electrical. Okay, so like if you already know, please skip this one. Otherwise, stay on this video and learn the things. Okay, right. So when we are talking about circuits means what? Like if you want to pass electricity, because like any machines, whatever machine you take, it works on the voltage, power, electricity, right? So that electricity you can provide through the batteries or power banks or like directly from your plug points in the houses, right? So like when you're like owning the switch or when you give the power, how it works, like how the power flows, that is very important, right? So there are few things you should keep in mind. When you are making a circuit, it's must for that circuit to be closed. If the circuit is open anywhere, not closed, okay, please follow the screen. So if it is open, the electricity won't flow, it will stop. If you keep a bulb, like for an example, I have a circuit, this, imagine this is the copper wire, okay, this one is the copper wire, and I have a small bulb, electric bulb or LED bulb, it can be anything, okay. So this bulb doesn't light up even though I supply power. Like for an example, imagine like I have few batteries here. Okay, these are the batteries. So when I have batteries and I have a circuit, I have a bulb, but this bulb don't lit. The reason why, because this circuit is not closed. It's starting, the electron starts to travel from here, but it cannot completely come back here to go for the second round. So the light cannot work, right? So how we can make the light work in a very simple circuit? There are so many things included, but we are going from the very basics, okay? Right, so let me draw again a completed circuit, how it will look like. So I'm going to draw a circuit like this. Okay, then don't think like circuit should be always the rectangle, okay? So to break that one, I'm going to draw it with a pencil. So any copper wire, like you know wires, right? So you can take any wire which should have some conductors. So like in science you might learn, in the world only there are two things. One is a conductor and other one is the insulator. So what is the difference between these two are, conductor can pass the electricity. So it will allow the electricity to flow through itself, right? That is the conductor. Insulator means it cannot allow the electricity to pass through. It will block the electricity. Okay, so the good example for the conductor where we use in the wires are the copper wire. Copper is the very good conductor, but you don't see the copper in the wires usually because it will be covered with the plastic, right? So you will see some green, red, those are the plastic covers, but inside there will be a goldish color copper will be inside. So that copper will be a conductor and it can pass the electricity. But if you don't want to pass the electricity, you can keep any insulator. One of the simple example of the insulator is the air. Why? When I disconnect these wires, when I don't connect these two wires, why electricity doesn't pass is actually in between these 2 points, there is a air, you know, air, like wherever you will see the air, right? So this air is a insulator. Or any wooden stuff, wood also insulator. So if you connect, even though you complete this circuit, but you complete with a wooden rod or something like that, then it cannot complete. If you keep a bulb, it's not going to work because this is an insulator. So insulators doesn't pass the electricity. conductors will pass the electricity. Okay. Now we will again come back to our circuit. Now I'm going to have a, so this is the copper wire, and I of course need a power supply. If the electricity should pass, like copper wire itself cannot produce the power, right? So it can only pass it, but it cannot produce it. So to supply the power, either I need a batteries or power bank or some way of the source for the power. So I'm going to add two batteries here. Okay, so you can ask why I am drawing like this. So if you want to draw a battery, usually we will draw one large line and one small line. So that is one battery. So I'm going to make another one. So another large one and another small one. So what does it mean is each battery, I'm pretty sure every one of you know about the batteries, because at least when you were small, like 3-4 years, you play with the cars and some toys, and those toys to function, you will need to put the battery, right? So in the how you will put a battery, like so, if there is a battery looks like this, okay, so every battery will have a plus sign and a minus sign. So when you are putting the battery, you should first check how you had to put it, because you cannot put other way around. Like so, they will put a small mark in your that battery box, the holder, like where you had to place the plus side and where you had to place the minus side. So to show that only when you are drawing a battery like this, the big line says this is the plus side and the small line shows this is a minus side. So plus, minus, plus, minus. Okay, right. Now I'm going to complete this circuit. But if I just complete, yes, the electricity going to go through, the flow of electricity is there. But you cannot identify there's a electricity going through or not, because you can't see the electricity with your like naked eye, right? Like so, you can't just see it. So to prove that there is a electricity flow is there, we need something to show up or light up. So you can use a normal bulb, or you can use a simple LED, because LEDs are cheaper and it's easy to carry and all, right? So I'm going to take an LED bulb. So LEDs are usually look like this. Like, how can I show that one? So I will draw it. I'm not good in drawing, so it will be look like this, and it will have two things. One is anode, one is cathode. Okay, right. So when I like join this LED light, when it's a closed circuit and the closed circuit is closed with a conductor, this one will show you more brightness, a light lit up. Okay, but if you disconnect this, like somewhere, if you remove that connection, like if you cut the wire somewhere here, it's not going to light up. So it will be just low, like that means it's not dim, it doesn't even work. Okay, right. So this is the very basic of the electrical circuit. Right. Now, how you at your home, when you switch on, it lights up, and if you switch off, it goes off. The reason is how the switch works, to make you understand very simply. Like there will be like this, okay? The conductor will be like this when you off. When you on it, this conductor will go and touch this one. So when it touch, it's a complete circuit. So the electricity is going to flow and the light will light up. But if you off it, this one will come up. So what will happen is it couldn't complete the circuit. So when you can't complete the circuit, then light will go off. Okay. So this is the very basics of the electric circuit. Now I'm going to show you a TinkerCAD. So TinkerCAD is basically a 3D designing CAD, a tool. You can design 3D effect things, and also you can make electrical circuits or building stuff, or it's anything, and you can connect to the 3D printer and you can make a print of that particular object too. So now I'm going to use that one only for the simulation. So here I'm not going to use much for the designing. I'm going to use that for the simulation. So let me go to the TinkerCAD. So TinkerCAD, it's very simple. Like, don't think it's a big thing or the rocket science. So like if you type in your Google TinkerCAD, you will get the TinkerCAD. So if you click on the TinkerCAD, I already have an account, so it's already logging in. But if you are a new one, you have to create your own account. It's simply as giving your email and the password. Okay, so once you give your email and the password, it will allow you to log in every time and you will have your own account. It's totally free. You don't need to pay anything. Okay, right. So let me go back to my TinkerCAD. So I have an account, so it's already logged in. Right. So here, if you see, there are some tools available in your right-hand side, and there is something to show code because you are going to write code, and then you can simulate it by clicking on the Start Simulate. Okay, and if something goes wrong, you can undo it, and if you need some wires, you can get it from here, and you can change it. That we will see. We will learn about this tool later on. Now, what I want to show you is how these circuits are going to work. So here we are making a color lights. That means, like when you are driving a car, every intersection, every major intersections, you will see a color lights. And if it turns to red, you have to stop the car. If it turns to green, you have to take the car. So how to make a color light? Let me simulate it and show it's working. See, it's red light, turn to green, turn to orange, and turn to red. So this continuously happen. Like through the code, you can change the wait time. So if you want green light for a long time, you can change it. Or if you want red light for a long time, you can change it. It depends on the code. Okay. So now I'm going to stop the simulation. So I have to explain you a few things. Right. First, don't worry about this Arduino. That is with the coding. But now I want to show you only the circuit part. Here, it's a simple circuit. If you take this line, it's just simply a complete circuit. But you see some extra stuff here. What are those? These are called resistors. You see in the toolbox, this is a resistor. Okay. So each resistor will have some amount of resistance. So why we need this resistor? Okay. So resistor to control the voltage or control the current flow in your circuit. Why we need to control the current flow? Okay, you have only one power supply, a power bank, that produces a voltage of 10 volt or 1000 volt or whatever, some amount. But your LED light needs only, example, I'm saying an example, only 10 volt. Okay, so if you supply too much of current, it will burn. So you cannot supply low level of current, then it doesn't work at all. If it doesn't have sufficient current, it doesn't work. If you give too much, it will burn. So to control that, you can use the resistance. So if you have 5 batteries in a power bank already built in, you can remove those batteries. So you can use that one but you can use the resistance to reduce that current flow. So that we will learn in the other video how the current flow happens. So there's a equation, I is equal V over R. So I is the current flow, V is the voltage from your battery or power supply, how much voltage is coming in, and the R is the resistance. So how much resistance you have to give, like you are giving something against to the voltage, so it will reduce it, and it will, like, there will be a current flow. So by calculating that, you can use how many resistance you have to use and how many batteries you have to use. Okay, so the resistance usually we measure in the measurement unit called ohm. So like by changing this number, you can increase the resistance or decrease the resistance. Okay, that's why they gave these 3 new things. These are the resistance. Okay, so this one we will again go through in another video with more details how to calculate I. So I is equal V over R. How we will do some exercises also and all the stuff, right? Now we will slowly go to the coding area. So now if you make this circuit, okay, like it can work, okay, so either green light might work or red light might work, only one will work. But I wanted to write a program to make these three lights lit up, like, but depends on the timing, like exactly like our road color light. Okay, so how to do that one? Then you have to write a code. So let me go to the code editor. So here I'm showing both block based and the text based, because this TinkerCAD by itself, by default, it's coming with a C++ coding. So don't worry, if you don't know C++, how I am going to write, don't worry. They are allowing the block-based coding also. So till you learn this C++, you can use the block-based to write it. So it will automatically convert and show how you have to write the text-based in C++. So what I am doing here, first of all, the very basic thing, like this Arduino, here they will, each pin, they will have a number. So if you connect the red light here, they are connecting to the 0. Then the orange light, they are connecting to the 1. And green, they are connecting to the 2. So you should be aware where you are connecting those wire is important to write the code. So here in the code, we are saying the pin 0 by default, when you are starting, when you start to supply the power, first, the pin 0 should have the high voltage, like the enough sufficient voltage, the current should pass through. Other two should be in low. That means who is connected to the pin 0? The red. So when you start simulating this one, so first light up will be the red light. Sorry. See? Okay. Then it's changing. So by default, when you are starting something, what should happen? So it's a very straightforward English. On the start, the pin 0 should have the current flow. Other two should not have. So other two lights is not going to light up, and only the red light will show. Then we are going to say continuously. Forever means it's a repeating loop again and again. What you have to do is, once the red light start up, when you start it, wait 2 seconds and then like disconnect the current to the pin 0 and give the high current voltage to the pin 2. So who is connected to pin 2? The green light is connected to the pin 2. So after 2 seconds, green white light will be available. Then go back. Now I go back and check. Again, they are asking to wait for 2 seconds to show the green light. Then they are changing the power supply by orange to supply the power, and red and green doesn't have. So now orange light will come. Then again you are waiting for 2 seconds and change it and make again the red light happen. So this will happen again and again. Okay. So this is the code how you will write it in the C++. So I don't go to that one right now because we will go from the basics. Right. So now I will again start simulation. So you will now understand how the code works. So you know, like 0 is connected to the red. So on the start, the red light should show, then green, then after 2 seconds, orange, then again red, it goes continuously. So let me start the simulation. After 2 seconds green, again after 2 seconds orange, after 2 seconds red. Okay, so it will continuously happen. Now I wanted to change the delay time, like for the green should show more, like I want to let the vehicles go more because this side of traffic is more than the other side. So let me stop this simulation and I'm going to give a delay for the green, which is the green, this one, right? So the green, I'm going to say, keep that for 5 seconds. Okay, now let's see what happens. Now let me start the simulation. Red is lightning in 2 seconds green, but the green is going to stay for for 5 seconds. See, then orange, then red. So orange, red are quickly changing, but green stay for a long. Okay, so by changing your code, you can play around with this one. even you don't want to, you want some signal to be always red, and some, because of some construction or something, you want to block the road. So you can continuously say, you can take other code and say continuously this red light is high. Okay, so hope you guys enjoy this video. So this is the very basics of how the current flow happen, how to make the circuits, and how you can start up with a very simple code to make a traffic light using Arduino. Okay, so this is called Arduino. Okay, you can use either Arduino or you can use the Raspberry Pi, but it depends on your need. For this small need, you don't need to buy the Raspberry Pi. You don't need it at all. But for some, like when you are doing projects with more sensors and those kind of things, then you will need a Raspberry Pi. Okay, right. Enjoy the rest of the day. See you in another video. Bye for now.